into, sorry, one more row. So I'm writing the question again. X, Y, Z, A, H, G, H, B, F, G, F, C into X, Y, Z. You have to find what is the order of this product. When you multiply these three matrices, you will get an answer, isn't it? So what is the order of that answer? What is the order? So without multiplication, you have to do this. Okay. Yeah, you can say that by checking the order of the given matrices, isn't it? So this is a what matrix? This X, Y, Z is a row matrix, right? 1 by 3. Its order is 1 by 3. Then what of the order of this one? That is 3 by 3. So what will be the answer of these two matrices? It will be a 1 by 3 matrix, isn't it? Now, this matrix is of what order? This is a column matrix having single column, 3 rows. So 3 by 1. So what will be the answer of 1 by 3 and 3 by 1 matrix? It will be a 1 by 1 matrix. It will be a 1 by 1 matrix. Yes, 1 by 1 is the correct answer. One by one matrix. Yes, Jishna, correct? Gopika, what answer you got? Manu, Envy, Kiran, Isaac. What about you people? Are you getting the answer? Okay. Isaac. What answer you got, Isaac? So those who have completed, write the next question. If matrix 2, 3, 4, 1, if matrix 2, 3, 4, 1 into matrix 5 minus 2 minus 3, 1 is equal to 1 minus 1, 17 lambda, find lambda. If matrix 2, 3, 4, 1 into matrix 5 minus 2 minus 3, 1 is equal to matrix 1 minus 1, 17 lambda, then what is lambda is equal to? What is lambda is equal to? Or find lambda. Okay. So for doing this, don't try to multiply the entire matrix. You can just multiply the second row and second column. Then you will be getting the last element. Second row and second column. You can multiply second row and second column. So what do you get? 4 into minus 2 plus 1 into 1, isn't it? So minus 8 plus 1, you'll get minus 7 as the answer. Tell me whether you're getting. Now don't go for multiplying the entire matrix. You can multiply whatever is required. Yes, Josephine, Gopika, correct. Next question. So we'll do some questions from this chapter, then we'll be going to determinants today. If A is equal to 4x plus 2, 2x minus 3, x plus 1 is a symmetric matrix, is a symmetric matrix, find x. Find x. Tirtha, you're getting negative 7, right? Not positive 7, negative 7 you might be just getting. Okay. Do the next question. If A is equal to matrix 4x plus 2, 2x minus 3, x plus 1 is a symmetric matrix, find x. Okay. So you're given with a matrix which is symmetric. What do you mean by symmetric matrix? Symmetric matrix means A is equal to A transpose, isn't it? So here 4x plus 2, 2x minus 3, x plus 1, that is equal to its transpose. So transpose is 4x plus 2, 2x minus 3, x plus 1. So this is equal to this one, isn't it? X plus 2 is equal to 2x minus 3. So simplified, you get 5 is equal to x. Yes. Gopika, correct. Jishna, check it. So we have studied what is a symmetric matrix yesterday. Based on that, you can do this one. Got it, all of you? Okay. After completing this much, all of you just let me know. After completing this question, I want the reply from everybody whether this much questions is clear, any doubts you are having. Okay, so there is a small topic that is left from this chapter, matrices. Before going to determinants, please write that. Please write the heading, special type of matrices. Special types of matrices. That means some matrices that you have to study additionally, especially for your ND exam. First one is orthogonal matrix. Orthogonal matrix. Yes, Jishna, which was the question? Can you say the question? What was the question that was there for homework? Jishna, is it 1, 2, 3, 4, A is equal to 1, 2, 3, 4, B is equal to 2, 3, 4, 5, 4A minus 3B plus C equal to 0? Was that the question? 4A minus 3B plus C equal to 0? Okay, Jishna. Okay, I got the question. Yeah, I'll do that after mentioning about the special types of matrices. Okay. Okay. So special types of matrices. First one is orthogonal matrix. Orthogonal matrix is a matrix such that if we multiply the matrix, suppose A, with its transpose, I am getting the answer as identity matrix. Then such a matrix is known as orthogonal matrix. Please note down what is an orthogonal matrix. Orthogonal matrix is a matrix such that A into A transpose is equal to I. Orthogonal matrix is a matrix such that A into A transpose is equal to I. A into A transpose is equal to I. That is known as orthogonal matrix. Understood? Is it clear? That means if we have a matrix A and we are finding the transpose, then we are multiplying these two, you will get the answer as identity matrix. Such a matrix is known as orthogonal matrix. Okay, next one. Conjugate of a matrix. Conjugate of a matrix. Next type of matrix we are seeing is conjugate of a matrix or conjugate matrix. Example, write with an example only. If A is a matrix, 1 plus 2i, 2 minus 3i, elements are complex numbers here. Okay. 4 minus 5i, 5 plus 6i. If these are the matrices, these are the elements of the matrix A, then its conjugate matrix is denoted as A bar. A bar is the conjugate matrix. A bar is the conjugate matrix, and that is given by, so this is the conjugate matrix. And it is given by 1 minus 2i. That means change the sign of the imaginary part. So 2 plus 3i, 4 plus 5i, 5 minus 6i. 1 minus 2i, 2 plus 3i, 4 plus 5i, 5 plus 6i. That means you change the sign of the imaginary part, that will become the conjugate matrix. That is the conjugate matrix. Please tell me whether you understood or not. Conjugate matrix. All of you? What is a conjugate matrix? Is that clear? Isaac? Manu Envy? You didn't send me the notes yesterday. I told you to send it. Is this clear, Devdutt? Conjugate of a matrix? Next type of matrix is Hermitian matrix. These are for your ND exam. Okay. Hermitian, Hermitian, Hermitian matrix. Hermitian matrix. It is a matrix such that for such a matrix, listen, for a Hermitian matrix, suppose I am calling that matrix as A. This is my Hermitian matrix, means if I take the transpose, first, if I take the transpose first, then I am taking the conjugate. If I am taking the transpose, then conjugate. If I am taking the transpose, then conjugate of that, I will be getting the same matrix. Such a matrix is known as Hermitian matrix. What I'll do, I'll first take the transpose. Then I'll take the conjugate. Then if I'm getting the same matrix as answer, that is known as Hermitian matrix. That is known as Hermitian matrix. Understood? Next is skew Hermitian matrix. Skew Hermitian matrix. Fourth one is skew Hermitian matrix. Skew Hermitian matrix. Okay, listen carefully. Skew Hermitian means I am taking the transpose of a matrix and taking its conjugate. I am getting minus A. Then that matrix A is known as a skew Hermitian matrix. Understand it carefully. I am taking the transpose, then taking the conjugate. Taking the transpose and then taking the conjugate. I am getting negative A as the answer. Then that type of matrix is known as skew Hermitian matrix. Skew Hermitian matrix. So that is a those are the 4 types of matrix, special matrices that you have to know. Please read these things. Any doubts you are having, please ask. Read the questions. No, we have to take the transpose, then conjugate. Not the other way, Govika. First take the transpose, then take the conjugate. Next question. Write the next question or last question from this chapter. Yeah, we'll do the homework question also. So please write a question now. Question is the matrix 0 minus 4 plus I, 4 plus I, 0 is options symmetric matrix, skew symmetric matrix, Hermitian matrix, skew Hermitian matrix. Okay, so first let's check this matrix. So what is the matrix? 0 minus 4 plus I, 4 plus I, 0. So if I take a transpose, what I'll get? 0 minus 4 plus I, 4 plus I, 0, isn't it? This is the matrix. Now listen, A here is A transpose. A same as A transpose? No, that is not true. So this is not a symmetric matrix. This is not a symmetric matrix. Now check whether A transpose is equal to minus A. Check it. What is minus A? Minus A means 0, 4 minus I, minus 4 minus I, 0. So is A transpose is equal to minus A? No, it is not also not same. A transpose is not equal to minus A. So that is not a skew symmetric matrix also. It is not a skew symmetric matrix. Now check whether it is a Hermitian matrix. How to check whether it is a Hermitian matrix? You have to take A transpose, then conjugate. So A transpose already written. Take the conjugate. A transpose is given. Then take the conjugate of A transpose. You will get 0, 4 minus I, minus 4 minus I, 0. Now A transpose conjugate is same as A here. Is this satisfied here? No, that is not satisfied. So this is not a Hermitian matrix also. Now check whether it is a skew Hermitian matrix. A transpose conjugate is same as minus A? Yes, that is satisfied. So it is a skew Hermitian matrix. It is a skew Hermitian matrix. That is option D. Option D is the correct answer. It is a skew Hermitian matrix. Skew Hermitian matrix. Any doubts you are having, please ask from this special types of matrices. Okay, students, now a question that Jishna has asked me from our homework. Question was 3x, y, 2z, 3w, isn't it? Is equal to x plus y, x minus y, z plus w, z minus w plus 3x. Was that a question? Any mistake in the question? Was that the question that I given? Okay. So listen, you have to find x, y, z, isn't it? X, y, z, and w. So what we can do is just equate it. That will be enough now. Just equate this and find out the value of x and y. These two matrices have given, if they are given is equal. So 3x is equal to x plus y. That means 2x equal to y. Let it be there. Then what they have given? This is x plus 4. Sorry, that was a mistake from the question. Okay. This is x plus 4. That's why you were not able to solve it, right? Okay. This is x plus 4. Jishna, it is x plus 4. Maybe that you are unable to solve it. You were not able to solve it, right? It was like x plus 4, 3x, y, x plus 4. Otherwise also, whether anybody got the answer if it was y, 3w is equal to z minus w plus 3x. In that case, you get, yeah, then also, yes. Okay. It is x plus 4. Jishna, it is x plus 4. Maybe, I don't know whether I have given wrong question or you have copied that wrong. It is x plus 4 here. Gopika, did I give x plus 4 or x plus 5? So if it is x plus 4, you will get the answer first. 3x equal to x plus 4. 2x equal to 4. X equal to 2. Then when x equal to 2, you know x minus y equal to y. So x equal to 2y. So y you will get as 1. Then remaining portion you can solve. 3w is equal to z minus w plus 3x. 3x is 3 into 2, that is 6 now. 3 into 2, 6. Okay, so from that you will get 4w is equal to z plus 6. Then from this equation, you will get z plus w is equal to 2z. So solve it, solve them, you will get z as 2, w as 2. Z as 2, w also as 2. Yes, correct, Gopika. Okay. So hope others have got the answer. Okay. So I'll give you 5 minutes. Go through the entire chapter. Any doubts you are having, you can ask me now. Go through the entire chapter. We will be starting the new chapter, determinants, after that. Determinants. So I want all of you to go through the chapter metrics and let me know whether you have any doubts. Okay, go through it and tell me. All of you go through the chapter. Any doubts from the beginning of this chapter you are having, please ask now. Adarsh, Betty, Irul, Devika, Devdutt, Dia, Gopika. Anybody? Okay. So write the new chapter. Determinants. Determinants. I have told you from matrix plus determinants. Totally, you will be having up to 7 questions in your ND exam. Maximum 7 questions. Matrix plus determinants. Okay. So listen. What is a determinant? What is a determinant? Listen carefully. That means, suppose I am having a matrix. Suppose I am having a matrix A. I am having a matrix A. Then its determinant is given as determinant of A. Then its determinant is given as determinant of A. This is a symbol. Suppose I have a matrix A. Its determinant is denoted as like this, with 2 lines, and inside that you will write that matrix. This is the symbol for matrix determinant. or it will be denoted as determinant A, like this, DET A. Okay, so this is the symbol for determinant. Okay, now let me show you how to find the determinant. How to find the determinant. Okay, so first I'll show you for what is it for a matrix of order 1, then order 2, then order 3. Okay, and before that, listen, the determinant we will be performing for a square matrix. For a square matrix. Determinant is performed for a square matrix. So first, listen, if I am having a matrix A and it's having only one element, A11, its order is 1 by 1, isn't it? 1 by 1 matrix. Then its determinant is determinant of A, and the answer is what itself? Answer is A11 itself. Because I do not have any other elements here. So its determinant is what? The element itself. Understood? This is for order 1. 1 by 1. Or a square matrix of order 1. Is it clear? That means if I am finding the determinant of a matrix which is having only one element, the element itself is the answer. Got it? Now listen. Got it, all of you? Yes. Next thing. If it is of order 2, that is a square matrix of order 2 means 2 by 2 matrix, isn't it? Then if I am having a matrix A as A11, A12, A21, A22. This is my matrix. Suppose this is my matrix. How to find its determinant? How to find its determinant? Okay, listen, how to find it. Determinant of A is denoted like this, and it is A11 into A22 minus A21 into A12. A11, A22 minus A21, A12. Just cross multiply like this. You multiply like this. Again cross multiply like this. Then subtract. Understood? Next, I am going to show it for a 3 by 3 matrix. For a 3 by 3 matrix. So before that, I need a reply from everybody. Is it clear how to find the determinant of order 1 and order 2? Yes. Now order 3. Order 3.